Alright, so 1, 2, 3, we're classifying by their angles and sides. And so, number 1, if we look at the sides, we notice we've got two sides marked congruent. So that is going to be isosceles. And then, if we look at the angles, this angle between those two sides that are congruent is apparently bigger than 90 degrees, making it obtuse. So it's an isosceles obtuse triangle. Number 2, we don't have any sides marked congruent. So that tells us that it's a scalene triangle. And this angle is marked at 87 degrees. The other two angles are very apparently less than 90 degrees. So that means all three angles are acute angles, making it a scalene acute triangle. Then number 3, once again, we don't have any sides marked congruent. So that means it's a scalene triangle. But we have this little box here that means that it's a right angle there. So it's a scalene right triangle. Okay, so then number 4, one acute angle of a right triangle is half the measure of the other acute angle. What's the measure of each angle? Well, it tells us it's a right triangle, and then we're trying to figure the measure of the two acute angles. So we know that those two acute angles have to add up to 90 degrees. And so it tells us that one is half the measure of the other. So if one is x, then the other one is half of that, or half of x. And adding those two together has to equal 90 degrees, since they're the two acute angles of a right triangle. Most people don't like fractions, so we can multiply by that denominator of 2 on both sides to get rid of the fractions, which will give us 2x plus x equals 180. Or combine the x's, we get 3x equals 180. And then divide both sides by 3. So we get x is equal to 60. So that's one of our angles. The other angle is half of x, or half of 60, which would be 30. So our two angles are 60 degrees and 30 degrees. Number 5 tells us in triangle ABC, the measure of angle A is 32 degrees, the measure of B is 4 times the measure of C. Find the measure of angle B and C. So, if I've got a triangle ABC, tells us that A is 32 degrees, and B is 4 times the measure of C, so we would call C X, which would mean that B would be 4x. And we know that all three angles of a triangle have to add up to equal 180. So 32 plus 4x plus x has to equal 180. Or 3x plus 5x equals 180. Or not 3x, 32. (32 plus 5x equals 180. So subtract the 32 from both sides. So that gives us 5x is equal to 148. Divide both sides by the 5. And so x is going to equal 29.6. So That means C, which is equal to X, is going to be 29.6 degrees, and B is 4 times that. So 4 times 29.6, which is 118.4. So 29.6 degrees and 118.4 degrees for C and B. All right, number 6, it wants us to identify the congruent corresponding parts of the two triangles over here. So we just have to look at the congruence marks and match up what has the same congruence marks. So A and E both have one angle mark in them, so angle A is congruent to angle E. And then B and D both have 2, so angle B is congruent to angle D. And then C and F both have 3, so angle C is congruent to angle F. And then we match up the corresponding sides. And so we got side AB is congruent with side ED. And side BC is congruent with DF. And side CA is going to be congruent to FE. Now on all those sides, we could have them in reverse order as long as the letters match up in order. So it could have been BA and DE, CB and FD, and AC and EF, just in opposite order there. And number 7 tells us if A equals 51 degrees, so if A is 51 degrees, and F is 106 degrees, what's the measure of angle B? Well, we know that when we look at it, that F and C are both congruent angles. So if F is 106 degrees, then C is 106 degrees. And so the measure of angle B should be equal to those two angles added together, or measure of angle B plus those two angles, 51 degrees plus 106 degrees, should equal 180. Well, the measure of angle B is going to plus 157 equals 180. Move the 157 over by subtracting it. So we end up with the measure of angle B has to equal 23 degrees. Then 8, 9, and 10, these are kind of like that congruent triangles worksheet, trying to decide if there's enough information to prove the triangle is congruent, and then explain the answer. And so number 8, we've got one side marked congruent, WX and WY congruent to each other. We know that WZX is a 90-degree angle, and so that means that the other way, WZY is a 90-degree angle. And then WZ, that side between the two triangles, has to be congruent to itself. And so since it's congruent to itself, and this is a right triangle, if we look at the sides we've got, WZ would represent a leg for each triangle, and WX and WY would both be a hypotenuse for each right triangle. So from there, we can say yes by hypotenuse leg, or HL. And we know that because segment WZ was congruent to segment WZ by the reflexive property. Of congruence. And number 9, we got 2 different sides marked congruent and 1 angle, but that angle is not between the 2 sides, and the only postular theorem that we have that we can prove by 2 sides and an angle is side angle side, which requires the angle to be between the 2 sides. And based on the information we have, we don't have any way to prove that anything else is congruent besides the 3 things that they gave us. So this one's going to be a not enough info. And an explanation, we can say there is not a side-side angle postulate. Because that's all that we could prove it by is side-side angle, but that doesn't exist. Then number 10, I don't know if you could see it the way that was copied, but there were little arrowheads on those top and bottom lines saying that those 2 lines were parallel. So since those 2 were parallel, they gave us that VW was congruent to XY. That's all they gave us, but we know that WY is going to be congruent to itself. And then with those 2 sides being parallel, that makes YW a transversal. And so the alternate interior angles would be congruent, which then when we look at that, that gives us a yes by side angle side. And what we have to explain is that WY was congruent to WY by the reflexive property. Of congruence. And angle VWY was congruent to angle XYW by the alternate interior angles theorem. And 11, 12, and 13, proving or determining the value of x and y if it has an x and a y, or just solving for x if there's just an x. So 11, this triangle has the 2 base angles there marked congruent. So if we've got 2 congruent angles, then we know that the sides opposite those 2 congruent angles are going to be congruent to each other. So x plus 13 has to equal 31. And subtract the 13. So x is going to equal 18 for that one. 12, they give us an exterior angle of 108 degrees. And what we have to recognize or know is that an exterior angle is equal to the sum of the 2 non-adjacent interior angles. So the 2 angles that are not attached to it on the inside of the triangle, if we add those together, they should equal that exterior angle. So those 2 angles, 4/5 x plus x, should equal the 108. And once again, nobody likes fractions, so we can multiply by the denominator of 5 to get rid of the fractions. So 5 times 4/5 is going to give us 4x. 5 times x. It's going to give us 5x, and multiply 108 by that 5, and we get 540. Combine our x's, we get 9x equals 540, and divide by the 9. And our x value is going to be 60. Alright, and then 13, I realized that it's actually missing a part that you need to be able to figure out what x and y are. And that's that this side down here should be congruent to those other two sides that are marked congruent. And so once we do that, I'm sure you probably struggled since that wasn't marked congruent like it should have been. We know that if these two sides are congruent, that makes this triangle an isosceles triangle, and the angles opposite those two sides should be congruent. So if this angle down here is 60, then the angle opposite the other side should be 60 as well, which is our x. So x is going to be 60. And then if we look at the top side, we've got that big triangle on the top there has two congruent sides, making it an isosceles triangle as well. So the base angles have to be the same. So this angle is y. So the other angle would have to be y as well. And since we already know that x was 60, and we've got a right angle in there, we know two of the three angles, y would be the third angle. So y plus 60 plus 90 has to equal 180, or y plus 150 is going to equal 180. Move the 150 over, and so our y value has to be 30 degrees. So x is 60 degrees, y is 30 degrees. Alright, then 14 and 15 want us to place figures into a coordinate plane and label the vertices, and then give the coordinates of each vertex. So for 14, they want a rectangle with a length of 16 units and a width of 8 units, whose diagonals intersect at 0, 0. So if the diagonals are intersecting at 0, 0, that means that that rectangle has to be perfectly centered around the origin. So that means that the origin's in the middle. So if it's got a length of 16 units and a width of 8, then I'm going to go 8 to the right and 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Cutting 16 in half. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to go 8 on each side of the origin, and then a width of 8. So cut that in half. 1, 2, 3, 4. It's going to go above the origin by 4 and below the origin by 4. And so then we build our rectangle there. Looks something like that. Told us to label the vertices, so A, B, C, D, and then give the coordinates. All right. And so by the description, the diagonals should intersect at 0, 0, which it will when it's centered like that. And so the coordinates of A is going to be -8, +4. B is going to be +8, 4. C is +8 for the x, -4 for the y. And D is going to be -8 for the x and -4 for the y. That's 14. 15 wants an isosceles right triangle with legs of 12 units, whose vertex angle has the coordinates of 2, 4. The other vertices do not have any negative coordinates. So if the vertex angle is at 2, 4, 1, 2, up 4, that's there. And then if it's going to have no other points that are, or no other vertices that have negative coordinates, then that means that we have to go up from here. And so that's up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up 12. And then over 12, because both legs are 12. 1, 2, 3, 6, 7, 10, 11, 12. So an isosceles right triangle. Vertex angle is 2, 4. Let's call that A, B, and C. B would be at the point 2 on the X. And we went up 12 from 4, so that's 16 on the Y. And then C is going to be 12 over from 2, so 14 for the X. And 4 for the Y. So 2, 16, 14, 4, and 2, 4. Your labels may be different, but your coordinates for your vertices should be the same. All right, so then 16 wants us to place a figure in the coordinate plane and then find the given information. So we're on a right triangle with legs of 8 and 10 units. So 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So go 8 over, or 8 up and 10 down. Got my right triangle there. The legs of 8 and 10. I want us to find the length of the hypotenuse. So I need the coordinates of those two vertices, which are going to be 0, 8, and 10, 0. And to find the length of the hypotenuse, we use the distance formula, which, if you don't remember it, is x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. So we use our 2 points on each end of the hypotenuse there. So we're going to have 10 minus 0 squared plus 0 minus 8 squared. So it's going to be 10 squared plus negative 8 squared underneath the radical, or 100 plus 64 . So d equals the square root of 164. And we can simplify that a little bit if we want. 164, break it down as 2 and 82, which is 2 and 41. And 41 is 3 and not 3 and 17. Actually, 41 is just 41. So we got a pair of 2's. So we can pull out a 2 and call that 2 square roots of 41. Alright, 17 says a square with a perimeter of 32 units. Find the length of a diagonal. So if the perimeter is 32, each side is going to be 32 1/4 of that. So 32 divided by 4 is going to give us 8 for each side of that square. So it's going to be a square that's 8 by 8. And so we want the length of one diagonal. So we can use coordinates of that corner up there, which would be 8, 8. And the coordinates down here, which is 0, 0. So we're using the distance formula again. It's going to be 8 minus 0 squared plus 8 minus 0 squared. That's 64 plus 64 equals the square root of 128. And 128, 64 times 2. 64 has a square root, which is 8. So our distance is going to be 8 square roots of 2. Alright, then 18. We want to find the missing coordinates for D and B. And we got to base those coordinates off of the coordinates of the other corners that we have. So for D, the y coordinate is going to be the same as the y coordinate for A, which is D, and the x coordinate is going to be the same as the x coordinate for C, which is A. So D is going to have the coordinates of A, D, and then B down here is going to have an x coordinate that's the same as A, which is negative C, and a y coordinate that's the same as C, which is negative B. So B is negative C, negative B, D's AD. Alright, then 19, given that triangle OBH is congruent to triangle BDH, find the coordinates of H. Well, what we have to recognize, if those two triangles are congruent, then H is the midpoint of that side. And midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And so from there, our midpoint is going to be, we're using the coordinates of D and O. So we got 48 plus 0 divided by 2 and 48 plus 0 divided by 2. Or that midpoint is going to be 24. 24. Alright, so here we have a proof that we're wanting to prove that side FH is congruent to IF based on the given that FG is congruent to FJ and HG is congruent to IJ. So I'm going to go ahead and mark those congruent. FG is congruent to FJ and HG is congruent to IJ. So that's going to be our first statement. Segment FG is congruent to segment FJ, and segment HG is congruent to segment IJ, given Alright, so from there, since we've got these two sides congruent, then we know that the angles opposite those two sides of this big triangle of GFJ are going to be congruent to each other. So that's going to allow us to say that angle G and J are going to be congruent to each other. So angle G is congruent to angle J by the converse to the base angles theorem. And then from there, once we've got those congruent, now we've got a side, an angle, and a side. So that's enough to prove the triangle FGH is congruent to triangle FJI by side angle side. So we can say triangle FGH is congruent to triangle FJI, and that's by the side angle side congruence theorem. And so now we've got these two triangles marked congruent. And what we know about congruent triangles is that their corresponding parts are congruent. So FH is part of triangle FGH, or HF is a part of triangle FGH, and IF is a part of triangle FJI. And since those two triangles are congruent, then the corresponding parts have to be congruent. So that allows us to say that HF is congruent to IF based on that principle that corresponding parts of congruent triangles are congruent. Because if they're congruent triangles, then all the corresponding parts have to be congruent. So that finishes up the review. So study hard and hopefully you'll do well on this test. See you then.